In this video, I will be talking about moderators, which represent a very unique type of variable. In other words, something that we measure during the experiment. I will cover the definition of a moderator. I will talk about the types of different moderators, and I will be also looking at when they should actually be measured in your experiment. The best way to understand what a moderator is to think of it as a spice, because as any spice, it can enhance the flavor of your dish and it can substantially change the nature of what you're about to serve. So think of it as something which is very unique, which is very important to account for in experimental research. Let's say I'm running an experiment, it has only two interventions, two manipulations, manipulation A and manipulation B, and I am measuring my dependent variable, and visually you can see that here in between my main independent variable and my dependent variable, something exists, and this something is a moderator. So what a moderator is, it's actually a variable that is completely independent from your treatment, this independent variable here, that affects the relationship between your treatment and your dependent variable that you are measuring in an experimental setting. And the way that it can change this relationship is that, as shown here by plus and minus sign, it can strengthen or it can reduce or annul the strength of this relationship. It can also change the direction of your relationship, so it can either become positive or negative. And in explaining to you what a moderator is, I'm actually building on the seminal work by Byron and Kenny, which they published in 1986. It is about the nature of moderator and mediator variable distinction. It is a paper which has been cited more than 35,000 times. If you haven't read it and if you do not understand what a mediator is, I encourage you to read this paper. It is very educational. It was published in the Journal of Personality and Social Psychology. And as you can see here on the screen, I have a second bullet point for you saying that moderator forms part of your hypothesis. I will get back to that point later in this video. But for now, I want you to understand where moderator actually sits and how we visually present it when we are doing research. Conventional way to place a moderator is to make it hover above this relationship. That's how we visually show it. If you look at the schematic which I have here on the screen, it will become obvious to you that moderator represents another independent variable which affects this relationship. And moderators very often represent individual consumer characteristics, something about individuals or consumers that affect the interpretation of the message that you are trying to show them. This is what makes marketing and social sciences research quite interesting, but also quite challenging, because it demonstrates that from the consumer's perspective, if you are, for example, researching the impact of advertising on consumers, your message will not impact everyone, because how an individual processes this information will vary, and how individual will process this information is captured by this moderator. This is the variable that affects the direction of this relationship, but also its strengths. Not everyone will be influenced by your advertising, and this is exactly what's captured by the moderator. Let's have a look now at the types of moderators that can exist out there. The first type is categorical, and this is what I would be looking at in more detail. In case you're not familiar with such terminology as level of measurement, with such words as categorical, nominal, ordinal, interval, or ratio, I encourage you to watch a separate video on this channel, which is about the level of measurement. This is the basics of research, which you need to know as a student or as a researcher. If you do not know what these terms mean, please pause this video and then watch that basics of research video before you proceed with this one. So in looking at the types of moderators and categorical moderators first, I am building on Bayron and Kenny's work, which they published in 1986. You can see it at the bottom of the screen. And they have distinguished between 4 cases. I will cover all of them in this video, and I will tell you which of them apply to experimental research and which ones apply to maybe cross-sectional survey type of research. Let's look at the first case. And the first case which Bayron and Kenny suggest is when you have a categorical or nominal independent variable, your experimental intervention, and you also have categorical or nominal moderator. In other words, both of them have exactly the same level of measurement. Let's have a look at the first example for case 1 from Bayron and Kenny when both the independent variable and the moderator are categorical or nominal in nature. I will be using this example, which a lot of you who watched other videos on this channel will be familiar with. I used a hypothetical experiment where I hypothesized that consumers who are exposed to kinder schema intervention, in other words, intervention which features children or baby-like prompts, will result in a greater number of products chosen with skewed labels on consumers' part. So this is H1. How it's formulated. Then let's say I do my literature review and I hypothesize that a potential variable which may impact on this relationship could be gender. I may be saying, based on the readership of the literature that I've engaged in, that females should respond more positively to kinder schema manipulation. And this is exactly what is captured in hypothesis 2, which says that females will choose more products with good labels compared to males when they are exposed to a kinder schema manipulation. So in other words, they will be kind of prompted or nudged to pick more products if they are exposed to a particular prompt that is conducive to stimulating particular consumer behavior. Now, to make things more interesting, I am giving you a second example of a categorical or nominal moderator. Let's say I did different set of literature review and I didn't come across gender, but I came across preference for cuteness. In other words, how consumers individually exhibit preference for cuteness. Some people may like cuteness and prefer cute objects. Some consumers may not like it. So that is a consumer variation that I suspect in wider public, which may impact on this relationship between my intervention that I'm testing and the dependent variable, the consumer choices, the products that they pick with cute labels. And the question which sort of measures this preference for cuteness could be, because it has to be categorical, it has to be nominal in nature. So I may ask my participant, do you generally like cute things? And there would be 2 answer options, yes or no, which would qualify as a categorical or nominal level of measurement. My hypothesis number 2 is saying those who like cute things will pick more products with cute labels compared to those who do not like cute things in the kinder schema manipulation. So this is what this moderation is hypothesizing in this case. In other words, it's strengthening this relationship. Now, to make things more interesting for you, if you, for example, say that those who like cute things will pick more products with cute labels regardless of the manipulation, then that would be H3. And visually, you would represent it as a path from your moderator to your dependent variable directly. And in this case, if this is research you're hypothesizing based on the literature review that you've done, you would basically say that it doesn't matter what you're exposed to. If you like cute things, you'll pick them even if you do not see any kinder schema. I thought I would show this to you to demonstrate how exciting and how challenging research can be and how many different options your research may take place. It all depends on from which angle you research the phenomenon that you are studying. Let's go back now to our previous example where we have hypothesis 1, hypothesis 2, and we are hypothesizing an interaction. The question would be, how would you analyze this data? Very easy. You would be using ANOVA in this case, and it would be a 2x2 ANOVA. 2x2 means you have 2 factors that you are investigating. Your first factor is your manipulation A and B. That's the kinder schema versus control group. and your second factor is the moderator, which is categorical in nature. So you are doing a 2x2 ANOVA by modeling an interaction effect between those variables. What you will need to do in this case is you will have to model H1 as the direct path and then model the interaction between your first independent variable and the moderator. And you can do that statistically if you use SPSS or any other software. So we have now covered case 1. Let's have a look at a slightly different scenario because very often the moderators that we study, they do not have categorical nature. They may be more continuous. So let's have a look at continuous moderators. And this is what is captured by case 3 in Bayron and Kenny's work. Let me show you an example of a continuous moderator. To make things easy, let's stick with exactly the same example of preference for cuteness. We have just discussed it from the perspective of a nominal or categorical nature, but we all know that social scientists, psychologists, and marketers like to measure subjective phenomenon using continuous scales. So let's say you've done your literature review and you have come across a measure for individual preference for cuteness, which has more continuous nature. As you can see on the screen, we can ask our participants, our consumers, to rate on a scale from 1 to 7 how they like or dislike cute things. Now, lower scores here indicate lower preference for cuteness, and higher scores indicate higher preference for cuteness. In this case, our first hypothesis stays exactly the same. But because now our preference for cuteness has continuous nature, we can develop a slightly different hypothesis saying that higher preference for cuteness would strengthen the relationship between kinder schema and the dependent variable. In other words, will result in greater number of products chosen with cute labels. How can we analyze data with a continuous moderator? Obviously, now we cannot use a 2x2 ANOVA because our moderator is continuous. One of the options for you to analyze your data is to use process add-on into SPSS, which Professor Hayes has developed. And if you're not familiar with this approach, you can have a look at his book. There are a lot of tutorials on YouTube as well on how to run different sets of models. But what this software does in this case, if you are using a continuous moderator, it creates cutoff points. It identifies the points where the effect becomes most significant or most influential. It's quite interesting. Run it. It is a very interesting output you receive. I personally love it. It is very informative to see what happens in your data and at which cutoff point something becomes more influential or something is not significant until it reaches a particular point. The second way for you to analyze your data is to use ANCOVA, where this C here stands for a covariate, where you would use your continuous moderator, your preference for cuteness, which you measure on the continuous scale, as a covariate in your ANOVA. So it's not 2x2 ANOVA, it is an ANCOVA, and there are a lot of videos and tutorials as well on YouTube on how to run this type of analysis. So this is how you would analyze your data if you are dealing with categorical and continuous moderator. During your readership of the literature, you may have come across papers where authors use continuous moderators and then they dichotomize them. This is what is shown by low versus high option here, where what researchers do, they say, I am going to dichotomize my continuous moderator and I will split them into two groups. One of the groups will refer to lower preference for cuteness and the other one will refer to higher preference for cuteness. And the typical hypothesis in such a case would be those with higher preference for cuteness will choose more products with cute labels, which is the dependent variable, than those who have lower preference for cuteness in the kinder schema manipulation. So this is what you would see conventionally. And this is actually what is called moving from case 3 into case 1 as per Bayron and Kenny. They do talk about such dichotomization, and in fact, they talk about steps where particular effects kick in, and then you dichotomize and split your data based on it. What are the approaches to dichotomize data? What you may see in the literature, in some articles that you read, is that some scholars have split it based on the median of the data. Median split is being highlighted in the literature by Yokabuchi et al. In their 2015 paper as a popular method to dichotomize continuous moderators. But what they do, they caution researchers about this approach, and together with Rucker, they criticize it because they've done a number of simulations, and in fact, a lot of research has been done on this topic, suggesting that dichotomization could lead to type 1 error. If you want to read more about those papers, they are shown on the screen. But let's have a look at this issue in a bit more detail, because dichotomization, in fact, has a very long history in marketing. And there is a very interesting paper published in 2003 by Irving and McClelland, where they've done a very extensive research and review of articles which were published in the Journal of Marketing Research, Journal of Marketing, and Journal of Consumer Research, and they found that around 46% of all articles with predictors that were continuous in nature, they were relying on categorization of such a continuous variables. And they further found that the median split was one of the most popular methods. It was used in 66% of the cases, and other popular methods included picking a cutoff point or dividing on the middle scale, so from 1 to 7, divided kind of on 4. What they do in this very interesting paper, which I encourage you to read, they caution about this dichotomization. And they are looking specifically at the regression analysis and what marketing researchers has been doing in the years before 2003. And they are very skeptical about dichotomization as approach because it may reduce statistical power, it can result in type 1 error. While Irvin and McClelland looked at the conventional regression analysis and did not cover the topic of experiments in a lot of detail, another paper was published in 2008 specifically looking at the experimental design. And this is an editorial published in the Journal of Consumer Research by Fitzsimons. It is very interesting, and it's called Death to Dichotomization. Now, they build on Irvin and McClelland's 2003 work, and they refer to it for technical aspects. And I refer you to this paper as well if you want to look at more technical aspects of the estimation of your models. But what Fitzsimons does is, again, they caution about the dichotomization of the variables. And they look at different examples specifically for experimental research. And what they recommend instead is to use a regression analysis with a dummy variable coding for your independent variable for your manipulation, and then use regression analysis and spotlight analysis to understand where effects actually lie, where you can look at +1 standard deviation from the mean on your continuous moderator to see where different effects kick in. For those of you who are not familiar with a dummy variable, I will explain quickly here. It's a special way of coding your data when you assign a code of 1 for a particular aspect of phenomenon is present, and you assign a code of 0 for when it's absent. If we stick with our example, we can create a dummy variable coding for regression analysis for the spotlight analysis with a continuous predictor, where we would assign a code of 1 to Kinder schema to suggest it was what participants were exposed to, it was present, and 0 would designate the stationary condition, the control group where Kinder schema was not shown. So this is an approach for you to analyze your data with a continuous predictor without dichotomizing it. You would run a spotlight analysis with your regression with the dummy coding for your independent variable. Now here, having said that, I would like to caution you about more complex experimental designs where, for example, you have your third manipulation, right? And I have it here in yellow color. If you are going to use the suggested approach from Fitzsimons' paper, that means that you will have to have 2 dummy variable codings here. If you have, for example, 3 types of interventions captured within your independent variable. It would mean in this example that if you want to capture your Kinder schema, that would be your first dummy variable. And in this case, you would assign a code of 1 to Kinder schema And the control group and the third manipulation would be assign a code. So you will be recoding your data. You will be creating a new variable in your data set. And what this dummy variable captures is basically kinder schema coded as one versus the other two groups. So these other two groups get lumped together, all right? And the same happens in the second dummy variable. Here, for example, you want to see the effect of the first manipulation when it's present versus when it's not present. But what's going to happen here again is that those two very different interventions are lumped together, and you may have different data variability here. So what's happening here, I'm not criticizing a dummy variable approach, but what I'm alerting your attention to is that dummy variable coding, when you have more than two categories, means that you will be lumping to other categories or the other ones, if you have 4 interventions here, into the same bucket. And there could be some interesting data variation between each of the conditions. So you need to have really good statistical knowledge to actually estimate your model properly, and not to get lost in dummy variables and also spotlights interpretations. Now, having covered this, and I know this was very heavy and very technical, let's have a look at other cases of moderators covered by Bayron and Kenny, which do not apply to experiments. And this is cases 4 and 2, and I will explain you why they do not apply to experiments. Let's have a look at case 4. You instantly can see big difference here. Your independent variable is continuous. And you also have a continuous moderator. You should instantly have a light bulb above your head because it is very hard to have continuous independent variables in the experimental design, because we usually try to keep them as categories, a type of intervention that we are exposing our participants to, and then we are measuring the effects on them. So for me, when I look at case 4, which talks about continuous independent variable and a continuous moderator, I think only of cross-sectional design of a survey. And here, to make things also interesting, because Labubu is very popular, at the time of me recording this video, I'm using this as my dependent variable. And I'm measuring future purchase intentions for a Labubu, and I am doing a survey. And let's say I'm asking consumers how many cute products you already own. And I measure it from 1, or if you want, you can start from 0 to an indefinite number. And my hypothesis here is saying that the number of cute products consumers already have, because that's a continuous variable, will be positively related to their future intentions to purchase a Labubu, because Labubu can be also considered as a cute thing, a cute doll. And the preference for cuteness, which is continuous in this case, says that higher preference for cuteness will strengthen this relationship, the relationship between the independent and dependent variable. Now, I was thinking I will show you a case where it's actually possible to have a continuous independent variable in the experiment with a categorical moderator. But this is where I think I will branch out in a different discipline, because this was the only example I could come up with. And let's say we are doing research on plants and we're exposing them to different temperature. And let's say in one group we had 12 degrees Celsius, then 13, another group was exposed to 14 degrees Celsius, and so on and so forth. And our cutoff point is 18 degrees Celsius. Now we are exposing plants to different temperatures, and then we measure their growth in millimeters. And the moderator could be whether the measure was taken in a dark versus light room, and obviously there should be lower growth in a darker room compared to light room. Now, in this case, based on my understanding of the literature and my general knowledge, our independent variable is continuous, and what I've shown to you is an experiment, but this is where it is really possible to manipulate your intervention in a continuous way. If you can come up with a scenario, an example like this, where we can regress this on the dependent variable in marketing, please let me know, put the comments down in the description. I would really like to read this paper. Okay, let's move on now to the next case from Bayron and Kenny. And this is where they are suggesting that case 4 can turn into case 2 if you want to categorize your continuous variable. You want to turn it into a categorical one. But I have already explained the implications of it and the current debate in the literature, which exists in the marketing discipline regarding the categorization or dichotomization of your moderators. Another example where we would be dealing mostly with cross-sectional data is when you're measuring a phenomenon in time and you are not manipulating it. In this case, if we are looking at case 2 from Bayron and Kenny, and we have a categorical or nominal independent variable, we can ask, and if we stick with the Labubu example that I used, we can ask whether people currently own a Labubu, and we would expect that those who currently have one will more likely buy another one in the near future. And this relationship will be moderated by their continuous preference for cuteness. I hope that now you are more familiar with different scenarios that you may encounter as researcher, as a marketer, and you can easily tell when your data is cross-sectional, which is the current case, or when you are considering an experiment when you would manipulate something. Now, this was a very technical, cognitively loading video, but I hope that now you understand what a moderator is, what types of moderators you may encounter, whether you should dichotomize them or not. I hope you enjoyed this video and you're ready for the next one.